While the multiverse of cinematic science fiction plays with speculative what-if scenarios that revolve around the fictional character, scientists examine the cosmic implications for the whole universe. This takes us back to cosmic inflation. Inflation says that instead of an expanding ball of matter, energy, space, and time that started with the Big Bang, the early universe exploded into being faster than the speed of light from a size smaller than that of a subatomic particle. After research in the 1980s by Andre Lind, a professor of physics at Stanford University, the eternal chaotic inflation theory of 1986 suggests that instead of being a single spherical symmetric expanding balloon-like structure, our universe may look like a multiverse, a cosmic froth of many different exponentially large universes with different laws of physics operating in each one. 2014, researchers from the BICEP2 collaboration announced the first direct evidence for this cosmic inflation through observations made by the BICEP2 telescope of the cosmic microwave background, a faint glow left over from the Big Bang. Since the cosmic microwave background is a form of light, it exhibits all the properties of light, including polarization. According to co-leader Jamie Bach from Caltech, the team hunted for a special type of polarization called B-modes. The swirly B-mode pattern is a unique signature of gravitational waves because of their handedness. This is the first direct image of gravitational waves across the primordial sky. According to an article by the Smithsonian, this work offers new insight into some of our most basic questions. Why do we exist? How did the universe begin? These results are not only a smoking gun for inflation, they also tell us when inflation took place and how powerful the process was. This theory provides a mechanism for creating an infinite number of universes, or in other words, eternal inflation. Let's now look at those theories that suggest the possibility of an infinite number of universes.
Brian, I'm about to show you something that's gonna blow your mind. Do you know what the Big Bang theory is?
Yeah, the theory that the universe started with a massive outward explosion from a singularity of infinite mass and infinite density.
Check out the big brain on Brian. Good. Now take a look. The universe's cosmic background radiation, a kind of echo of the Big Bang, precisely matches the energy spectrum of my return pad.
What does that mean?
It means my return pad's explosion was the Big Bang.
But the Big Bang happened like billions of years ago.
No, we were outside the space-time continuum. Time and space didn't exist until my explosion, which means I created the universe, Brian.
Wait, that doesn't make any sense. You were born in the universe. How could you create it?
It's called a temporal causality loop. The universe created me so I could create it so it could create me, and so on.
That's the most incredible thing I've ever heard. So wait, that means that I kind of created the universe too?
No. You're sort of the Art Garfunkel of the universe.
Brain cosmology. The etymological root of brain is membrane. Brain, an object extended in one or more spatial dimension, arises in string theory and other proposed unified theories of quantum mechanics and general relativity. A zero brain is a zero-dimensional object, or a point. A one brain is a one-dimensional object, or a string. A two brain is a two-dimensional object, or membrane, and a p-brain is simply an object of p-dimensional spatial extent. Brain cosmology suggests multiple brains exist, each containing its own universe, floating parallel to each other in extra dimensions we can't perceive. These brains might occasionally bump into each other, and some scientists think these collisions could explain the Big Bang. Gravity might even leak between brains, which could help explain why gravity seems weaker than other fundamental forces in our universe. Even though brain cosmology remains a theoretical framework without direct experimental proof, of all the theories in cosmology about how our universe was created, the brain world theory presents perhaps one of the most exotic, hard to prove, and yet potentially elegant solutions on how all this came to be. String theory and the landscape multiverse. String theory, first envisioned by physicist Leonard Susskind in 1969, revolutionized our understanding of the fundamental building blocks of the universe. It proposed that instead of point-like particles, the universe is composed of tiny vibrating loops of energy known as strings. These strings can oscillate in different modes, giving rise to the diverse particles and forces we observe in nature. According to an article by The Medium, this theory portrays the existence of a vast multiverse, where each pocket universe is associated with a varied configuration of the extra dimension that string theory predicts. These extra dimensions, unlike our familiar 3 Euclidean dimensions, are hypothesized to be curled up into incredibly tiny loops or intricate shapes, far beyond our current ability to directly observe or interact with them. String theory is formulated in 10 and 11 space-time dimensions. In order to describe our universe, we must postulate that 6 or 7 of the spatial dimensions form a small compact manifold. In 1985, Philip Candelas showed that by taking the extra dimensions to the Calabi-Yau manifold, one could obtain the grand unified theories which had previously been postulated as extensions of the standard model of particle physics. The problem of extra dimensions continued to plague string theory, but these were solved by introducing the idea of compactification, in which the extra dimensions curl up around each other, growing so tiny that they're extremely hard to detect. One benefit of the Calabi-Yau manifolds was that the geometry of the folded dimensions give rise to different types of observable particles in our universe. If the Calabi-Yau shape has 3 holes, 3 families of particles will be predicted by the standard model of particle physics. Unfortunately, there are tens of thousands of possible Calabi-Yau manifolds for 6 dimensions, and string theory offers no reasonable means of determining which is the right one. For that matter, even if physicists could determine which one was the right one, they'd still want to answer the question of why the universe folded up the extra 6 dimensions in that particular configuration. The many worlds theory. In the early 1900s, German physicist Max Planck suggested that waves, like light, radio, and microwaves, emit energy not randomly or arbitrarily, but instead in discrete quantities which he called quanta. The quantum rules, which were most established by the end of the 1920s, seem to be telling us that a cat can be both alive and dead at the same time, while a particle can be in 2 places at once. The amount of energy released in a quantum is proportional to the wave frequency of the radiation type in question. Wave frequency is simply the number of waves that pass through a fixed point in a given unit of time. In Stephen Hawking's book, A Brief History of Time, he provides background on the uncertainty principle. Werner Heisenberg reasoned from Planck's theory that the very act of shining a quantum of high-frequency light upon a particle, which was the only way to measure its position and velocity, would, in and of itself, disturb the particle and disrupt its velocity. The very attempt at observation made it impossible to accurately gauge particle position and speed. This was the uncertainty principle. It marked the beginning of the new field of quantum mechanics. Quantum mechanics takes a probabilistic approach rather than an absolute approach. Obeying the uncertainty principle, it does not seek to establish a single definitive interpretation or result for quantum mechanics, and the uncertainty principle tells us that it's not as useful to think of the physical world as being composed of waves and particles. The many worlds interpretation, or MWI, of quantum mechanics holds that there are many worlds which exist in parallel at the same space and time as our own. The existence of the other worlds makes it possible to remove randomness and action at a distance from quantum theory, and thus from all physics. The difficulty with the concept of probability in a deterministic approach, such as the MWI, is that the only possible meaning for probability is an ignorance probability. But there is no relevant information that an observer who is going to perform a quantum experiment is ignorant about. Ignorance probability means when we make some claim with 90% probability, what we are really saying is that the knowledge we have allows us to make a prediction that is that much accurate. And the main point here is that different people may assign different probabilities to the very same claim. Professor of Philosophy of Physics, Simone Saunders claims to solve the problem without introducing additional structure into the theory while working in the Heisenberg picture. Philosophy of Science and Physics, Alistair Wilson, in 2013, also developed this idea by introducing a framework called indexicalism, which involves a set of distinct diverging parallel worlds in which each observer is located in only one world, and all propositions are constructed as self-locating or indexical. In Wilson's words, indexicalism allows us to vindicate treating the weights as a candidate, objective probability measure. With respect to the aforementioned theories discussed today, it is important to note that the countless other theories and experimental designs that have been modeled to seek the multiverse model of the universe. By considering a multiverse, scientists gain a framework to explain the fine-tuning of physical constants that make life possible, the nature of cosmic inflation, and even the puzzling role of dark energy. It expands the boundaries of cosmology beyond a single beginning to a vast landscape of possibilities. Ultimately, these multiverse models are not just a speculative idea. They are a powerful tool that push us to rethink the meaning behind how the universe began. They invite us to embrace the complexity and wonder of existence, inspiring new questions and guiding future discoveries in our quest to understand the cosmos at its deepest level. Thank you for listening. Simran out.